Welcome to the Tech Trek, where technology leaders share their insights, experiences, and views. Every week I bring you a new guest. And on today's episode, Pedro Alves. He is the CEO and founder of Ope.ai. We talk about how Opal's product is helping companies deliver at a fraction of the cost, the ROI of AI, some main points of how you can help establish that ROI, and the evolving role of data scientists. I hope you enjoy this show. Thanks. Hey, Pedro, appreciate you being on the podcast. Thanks a lot.
Thank you. It's fun to be here.
Absolutely. So I know I gave the audience a general overview of your background, but I can't do justice more than you can yourself. So if you want to give everyone a little intro to who you are, that'd be great.
Yeah. So I started, working in data science, AI, machine learning about 2001. Most of my career in AI has been in academia. I'd say, well, a little more than half, and then a little less than half has been in industry. I started off in the fields of genomics and proteomics, and then went into healthcare, a little bit of insurance, and then moved on to social media and fashion retail, mostly with computer vision around fashion. And through advising and consulting, then did some work with predictive maintenance, professional sports, and a few other things. So I've seen, companies from Fortune 50 all the way down to 3-person companies using AI in a lot of different industries, and interviewed about 300 data scientists over my career. So getting a lot of different angles of seeing the space from the manager, the CEO, the data scientist, to understand the whole ecosystem of AI within companies. I think that's something that I really like about my experiences I've had so far.
Absolutely. And what led you to Ope.ai?
So it was through those experiences, getting an idea of what I thought the state of AI was, and just a quick, travel down that lane of, okay, if a company wants to do AI, I think the first step is they'll try to hire people, which is already the first blockers, because there's few people that are very good. So it's very difficult to hire. And the normal path is about a year and a half to hire a team. After which most companies take another year to a year and a half to find out they hire the wrong people, firing them, and then starting over. And that's actually, sadly, the normal path, because companies don't even have the qualified people to know who's qualified to do this in the first place. And then let's say now you have a team, which, by the way, over 90% of the time, it's going to be some centralized AI hub within a company. And it's not by choice. It's because they know that if they're going to hire AI people, data scientists, for every department that wants it, right? The marketing department is going to have their own data scientists, and the sales department, the logistics, they can't hire that many data scientists. So they can't do that. So they say, well, because we can only hire fewer, we're going to build a centralized team, and then all the other teams are going to use this team to get their services done for them, right? Like an internal AI consultant, if you will. And the reason why that doesn't work is, it can never produce enough volume to satiate the thirst of all the teams around them. So you end up with a lot of people that are just waiting to get their turn to work with the data scientists. Secondly is, these data scientists are not immersed in their customers, basically, right? They don't understand the business, and they're removed. And so there's a communication gap there. I used to say that 90% of projects used to fail because of non-technical issues, meaning it's not, there's no good technology for it. The model's not accurate enough. I found out I actually wasn't far off, because Gartner came out with a number and it was 80%. So I kind of got confirmation. But just to break down what that 80 or 90% is, I believe half of it is problem formulation, because they don't understand the business. The people that are asking the questions also might say, hey, build me a model for X. They really wanted a model for X prime or Y, but then the data scientists will go and build that model, and then later realize, oh, wow, that's not exactly what you wanted. And then the second thing is much simpler. It's the end user doesn't trust, understand, or know what to do with the output of the model. One of those three things doesn't hit, and then the model gets shelved, So if you look at the math of how long it takes to hire a team, plus the cost of the team, plus a team that's half a dozen to a dozen is going to finish 3 to 6 projects a year, plus 80 to 90% of those projects fail, then that 10 to 20% of the projects that succeed, that doesn't mean they're going to impact the business. That just means they succeed from a perspective of what was wanted was built and it's accurate. Now you need to see, does it impact the business? And maybe, let's say optimistically 25% of those succeed and in impacting the business. So now you're talking about, maybe 25% of 10%, right? So small single digit percentage of projects impact the business. And you're doing 3 to 6 per year. Do the math, how many years you have to wait to get one project that impacts the business. So this, I think, is the ecosystem, and it's an ecosystem of frustration. Most companies are very frustrated with the whole AI as a business impacting tool. And the solution, in my mind, is what led me to Opal, a very long-winded way of getting there. But it's, okay, there's all these different problems. They seem unrelated, but I think that they are related. If you follow the path of why can't you hire enough people in the first place? Well, that's because it's really difficult, right? To be a good data scientist, listeners know you need to be a mathematician, statistician, machine learning scientist, software engineer, good communicator, understands the business. So there's very few people with all those skills, and that's the beginning of the problem. So let's say you take the technical part of data science and you try to automate it in the software, right? And by the way, the most valuable thing a data scientist can do in a company is not tuning a model and figuring out you need 1,233 trees on your random forest as opposed to 1,975. The most valuable thing a data scientist can do to the company is do problem formulation and think of what are the places we can use AI to improve the business. But if you take the technical part and put it into software and say now a data analyst, business analyst, right, a subject matter expert can use this software, now they can ask the questions and they can get the answers because they can use software to build the models, right? So now what you're doing is you're saying, okay, in the marketing department, you have a few people there that have questions and potential projects for AI, give them the tools to solve it. Now what you're doing is you're having, instead of half a dozen to a dozen people that can build these models in a company, you have hundreds of people that are already qualified to build these models. So you're solving the problem of hiring because you already have people like that. Then you're solving the problem of communication because communication is inside the person's head. They ask the questions, they now have the tools to answer the questions. So there's no problem with communication and understanding the business. It's the same person that asks the question and answers the question. And then you also solve the volume problem because now you have hundreds of people in every department doing that. So instead of finishing 6 projects a year, you have 100 people overall in every department, each finishing, 20, 30 projects a year, because instead of a 2-month process of tuning and feature engineering, it's a 1-hour process that's automated. So now you finish the year with, 1,000 projects that you finished. And even if only 2% of those impact your business, now you have projects per year that impact your business, right? And I think that's what led me to saying, okay, I need to build this piece of software. And that's what I think Opal is.
Interesting. And just I guess just to that note, to understand the product a little bit better, because I think it'll be interesting, is how, and I know, based on the website, it can be applied to lots of different industries. How deep does those, I guess, the models, the type of questions that you guys are, helping those departments answer, how deep does it get? Like, how granular can you get?
So I can give you a couple of examples. One is in the area of being in knowing what to do. So one customer had, they sold apparel online, and they had 50 email campaigns roughly, and they were called trigger-based campaigns. So they were, if you hit a trigger, you get an email. So there's an email for you haven't shopped in 6 months. When you hit that trigger, you get that email. There's an email for you put an item in the cart and you didn't buy it within 24 hours, right? What they know is that certain types of emails don't work well with certain types of customers, but they don't have any intelligence around building, like having a model that says, will they work for this customer? It's just you hit the trigger, you get the email. So this was a funny situation because the marketing department in this company had been waiting in line to work with the data science team for about 2 years. And because they had to build 50 models, the team and the priority was kind of low. The data science team was very honest and told me, we're never going to do that project. It would take our entire team 2 quarters, and we can't get off all the other projects just to serve that one team, right, for 2 quarters. So they're going to wait in like forever, basically. And the idea was, now it's automated. Can you just start feeding the data in and getting these models? It was done by one person in 1 month, as opposed to a team of 10 in 2 quarters, right? And now they had an email campaign that said, oh, they hit the trigger. Wait, now you have a model that says, what's the probability they're going to do what the email says, convert? What's the probability they're going to ignore the email? And what's the probability they're going to hit unsubscribe? So now after the person hits the trigger, obviously the model says, hey, high probability of unsubscribe, don't send this email. So that's one example. The same type of thing can be used for like retargeting, right? Which people you should retarget have the highest probability of closing. A second example that actually resonates with a lot of companies is with forecasting. Forecasting sales, forecasting churn, forecasting, right? Which products are going to do well. The interesting thing about this type of problem is that just predictions are not good enough. Let's say you have a nice model that predicts weekly how much you're going to sell, right? So now let's say it's really accurate, 100% accurate, but impossible, but let's say it is. It's still not useful. Let's say it predicts next week you're going to be 15% down in sales. Great. Now I know that's going to happen. And because the model is really accurate, that actually is going to happen. So now we're going to be 15% down in sales, knowing that doesn't really impact the business, right? It would be useful to know why and what you can do to change that probability. So that's where our software automatically producing model explainability on a prediction per prediction basis, saying this particular prediction is this because this value is like this and this is like that. So now you can actually do something about it and not just wait for the prediction to become true, right? And understand, why is this customer going to churn? Oh, because he only received, 5 contact touch points in the last quarter as opposed to 6. Oh, okay, well, maybe, we should reach out to them one more time, decrease the probability of a churn. So I think that the forecasting and then, in the marketing email campaign, there's a lot of examples also in related to machinery and factories predicting when they're going to break. That's another big use case. So I guess they do get pretty granular. There are some that are kind of generic and apply everywhere, like, things like in sales, right? Predicting, sales. I think almost every company has an example like that. But some things are going to be a little more industry specific.
If you say these are like micro models, obviously they're very defined models for very specific. You mentioned, I guess, in the first example, multiple models to address different parts of the email campaign, the trigger. How much of those require your product to get to a certain percentage? And then when do the analysts from, the people actually with the domain specific knowledge at the company or whoever's using this model, where do they come in? Like, where's the balance of how far you guys have solved the problem and when, the knowledge worker has to take over?
So they're the ones that are going to formulate the problem, right? They're the ones that are going to say, this is the problem we have. We send these emails. We know people unsubscribe. We want to predict when they're going to unsubscribe. They have to formulate that, and they have to have the data, right? And the person in the marketing department is the best suited person to do those things because they understand their business, so they can formulate the problems the best. And they also want to know what's the best data that represents that problem they have formulated. But once they have that, then they don't need to understand anything from, feature engineering to handling missing values and cleaning the data and building the models and tuning the models and even deploying the models and then getting model explainability on top of that. So that's where, we take over with the software. But then at the end, they have to do something, right? So having that model saying, yeah, this person is going to unsubscribe, they need to then not send that email. If it just makes a prediction, they don't do anything, then it's not really going to impact anything. So they're at the beginning and the end, right?
How much data? So you mentioned the data. Are you guys determining how much data they need to bring to the table for the solution to work? Is there like a minimum threshold? Otherwise, it's just not going to work, or will it work with any amount of data that you guys have figured out?
It's going to be super dependent on the problem. That's a really hard question to answer because the true answer is, sometimes I've done projects and I've seen papers published with a data set of 100 samples, right? 100 rows. And if that's all you have, then what you need to see is is it producing anything that's accurate enough to be valuable, right? That's really the measure, because it doesn't matter. Yeah, it would be great to get 98% accuracy. Is it valuable? I don't care if it's 52% accurate, right? Like if you look at, stock markets or counting cards in blackjack, the probability that they have the edge is like 1%, right? The most of those games in casinos, your probability of winning is just under 50. They want you to feel like you have a good chance of winning. And the people that count cards, they bump the probability up to like 52%. And that's enough to make money. So, that's where, yes, you could use more data, and we're actually introducing things in the software now to actually help you understand, do you need more data? And it'll tell you, yes, I think you need more data to get better. But if it's usable now, right, use it. Just, measuring an AI project has nothing to do with accuracy. It has to do with business impact, right? And so if it gives you business impact, that's good enough.
Sure. And like when you're talking about business impact and you're trying to measure, I mean, everyone's going to evaluate the ROI of undertaking the project. So something like this, where let's say companies approaching it where they've never actually implemented this type of model, this type of solution, where did they start to be able to look at to put together a framework of the go, no go? Like what kind of parameters are they looking at to make it a justifiable expense? And obviously, we'll take a step back in a few minutes and talk about some of the issues of implementing bigger AI projects and why this is a solution, like you mentioned initially, you brought to the table. But what parameters are they using to be able to go, this makes sense if we see these results? Or what kind of metrics are you seeing?
So addressing the point you made about these big projects, that's a side effect of the initial problem I mentioned, which is AI is so expensive and so time consuming, and it's the payback is so small that companies feel forced to only do the very big, ambitious projects, right? Because it's like, if it's going to be that expensive and take that long, I'm not going to do some small projects. So then they end up doing the projects that have the highest risk of not producing anything. When you lower the cost and you increase the volume of being able to produce AI projects, you can start to do the projects that realistically have a better shot of producing something. And the measuring is, first you start with, does it impact the business? And then I think there's three things you need to measure. But the example of does it impact the business is, let's say you sell t-shirts online and you have a lot of returns. It costs you a lot of money, $30 million a year of returns, just shipping back and forth, right? And you say, we need to predict returns, right? Because it's costing us $30 million a year. And then you have to think, how is that going to impact your business? Somebody orders a product, a shirt, and then they're going to return it. And you can predict that they're going to return it. There's nothing really to do, so it doesn't really impact the business. You need to think about, what can I change to help the business? Well, the biggest use case of when they return is because they bought the wrong size. Oh, okay. So we can solve the problem by building a model not that predicts returns, which is the original problem, but predicts t-shirt sizing. Because now when they're going to order, before we ship it, we say, hey, our AI model said that, because of this particular brand and shape of this shirt, you should really order this different size. And if they can convince the customer to buy that size, now they reduce returns. So right there, if you just play it out in your head of, once I have that model, what am I going to do with it? And then how is it going to impact my business? Quickly, you can get to an answer of, yeah, I can see how this is going to impact my business or not. And then once you figure that out, I think that there's three things you need to measure in an AI project. Thing number one is speed. What I mean by that is, let's say you have 5 engines, and they're very expensive engines. Anytime they're down, it costs you $1 million a day, and predictive maintenance would be great, right? But you also don't want to stop to fix it because it's costing you money that it's not running. So if they only break once every 5 years, and you only have 5 of these machines, the speed coefficient of this model is going to be really slow, because for you to measure that you actually now are making money off this model, it's going to take you years probably. Now, if you're ad tech and you make bids on which ads to show, and you make 1 billion bids an hour, and now you have a model that's 10% more accurate, and every time somebody clicks, you make money, you could probably wait 10 minutes and see that you're making more money. So you need to measure that idea of speed, right? The second thing is determinism of the model. What I mean by that is, if the model is more accurate, is it perfectly deterministic that yes, you make more money or not? So the ad tech is an example of perfect determinism, right? If it actually is more accurate and people are clicking more, once they click, you make money. That's how you make money. Or stock markets, right? If you predict the stock market correctly, no question about it, you make money. The example with the t-shirt I gave you, determinism is kind of in the middle, because you can have the model that's 100% accurate, always knows exactly the size of the shirt people buy, and people might not be convinced that the model is good enough, and then they just don't do what the model is saying. So it's up to, you need now a nice UI, right, that presents that information to the user nicely and convinces them to buy the right size. There's all these other elements that have nothing to do with the accuracy of the model, and there's still a human element of, are they going to do this? So the determinism of that project is in the middle, and then some are going to be very low determinism. So you need to figure that out. And the third measurement is impact. Something could be fast and super deterministic and give you an extra $100 a month. Impact is really low, so you want to make sure that if those things are true, what is the final impact? In this case, the t-shirt's $30 million. Maybe you cut that down in half, you can make $15 million a year. Impact is high. So I think just thinking through speed, impact, and determinism will help you understand. Hopefully, though, AI gets to the point that's ubiquitous enough and cheap enough that you can just try all the projects anyway. Right? That's the dream, I think.
Well, it's interesting. You brought up a very interesting issue of just solving the right problem, right? So you mentioned the return issues, and if that's the core issue that you believe you have, and you're not actually looking at the underlying root cause of what might be producing that with the wrong t-shirt sizing, that's where the model needs to be applied. Obviously, then it's difficult to yield the impact, whether it's speed, determinization, or the impact facets of the project. So when you're looking at the internal side, I'm just curious with the clients you maybe have worked with, do they always know the actual problem? So they understand the business, they know what the question is they want to ask, but do they always know where they need to go look for the problem, or are you guys actually helping them uncover, hey, it's the t-shirt sizes that are a core issue that you need to solve?
Yeah, I think that is a big gap still in how companies are thinking about this. It's certainly, I think, the place that needs the most education for companies and people within companies to understand how to ask those questions, which questions to ask. So we do see that a lot with people that we engage with. There are some that know, they just know, oh yeah, here's these 20 ideas, great, I can use this. But there are some that, even if you say AI now is easy, if you push a button and get a model, they're still going to be, okay, great. Which models? Like what should I do, right? So we see that quite a bit, and it's part of the process of educating people. And once they start getting a hang of it, oh, I solved one problem, I solved two problems, they'll start seeing much more easily, okay, I could start just probing around and try to build these models for these different things. Once you kind of like take out the blinders and they see how easy it is, I think, and they do one or two, they'll start actually thinking about it in a better way, and then it starts coming to them easily. But there's definitely a period of education for a lot of companies where they need to be, you need to work with them and helping them understand this. It's a good point.
Yeah, it's interesting. It correlates to everything you've been mentioning, because I read a study by PwC, and it mentioned that while AI engineers and the demand for machine learning is increasing, the actual functional analyst role in the next decade is actually going to be a massive delta over that, just because of what you mentioned. The people that can actually understand the business problem to the domain and to actually formulate it for a model to solve. So I think that was an interesting number I read, where while maybe the demand for AI engineers is X, you need I think close to 10, 12X of the analyst side to work with the models you're building and actually be able to deliver the value that somebody's investing in. So I guess when I was looking through your profile before, and I came across something, and it kind of tied into the premise of your company, what we talked about before on our pre-call. It was the poem you wrote about the waiting place, about AI and waiting. And I quite liked it, because I actually scrolled down and if you guys go onto Pedro's LinkedIn profile, and we'll include the link to it. But the poem was awesome, because it really touched on why you'd started this company and an actual AI that's tangibly in place, not the AI tomorrow of self-driving cars that might be here, maybe when my kid's, 16, I don't know, maybe at this point, past that point, but I quite enjoyed that. That was awesome.
Thanks.
So to kind of go back to maybe an area that we'd mentioned touching on, you talked about how you solve like the big moonshot and you're trying to get somebody to come down and understand, the idea of implementing something more narrow. How much resistance do you get with the people who are enamored with, I just want to make that big splash because this is just sexy and it sounds cool, versus not? Like, is there some mindset that people still view this as it's got to be the big bang and you've got to get over that? I know you mentioned that's higher failure rate in general, but how do you deal with the mindset?
I think that's something that we're not completely over, but I think fairly far in that process. Meaning, if you go back, I would say 2 to 5 years, I think the enamoredness of these people, within these companies, right? The leaders, whether it's a CTO or a director of AI, or some of these titles that are basically, AI falls under their umbrella. I think 2 to 5 years ago, you'd see a much higher incidence of this. No, it must be the moonshot. I think by now, most companies have already invested so much in AI and gotten so little back that now they're like, okay, no, any project that can give us some return on our investment, let's do it. And they're a lot more eager to, no, yeah, sure, small project, medium project, does it do it? Can we see a business impact? Let's go ahead and do it. I mean, there's still companies that are going to be in that, but I think the majority already passed it.
So I've been working with a few directors of data science that they're open to bringing on products that help like what you're doing, but what happens to their role in companies, right? Let's say if you're the director of data science at a company that's 250 people and you came on thinking, I'm going to build models, I'm going to answer questions for this company, I'm going to solve all these problems that your product can come in and solve, and he just needs to hire analysts. Where does he or she's role in this process change from going, I'm going to build models, versus I'm bringing a company in that's going to help me, unpack models?
So this is where it'll be interesting to see what percentage of the data scientists get ahead of the curve. My advice to the data scientists on how to improve has nothing to do with model building and accuracy. I mean, we actually have the number one caggler in the world, Gilberto, right? I think he's had like 57 gold medals. It's more than the other next 3 people combined. And even he agrees that the success of a project has so little to do with the accuracy. So whenever I go to a talk and people ask me, how do I get to be a better data scientist? And they expect an answer like, oh, use algorithm XYZ, or this is how you tune a model. It has nothing to do with that. And here's what it is. It has to do exactly with what you said. What is their role? So if you look at Tableau, people used to do what Tableau did at companies, right? They used to have people that just them that own that. And Tableau said, no, everybody can do this now. And they got displaced temporarily. Those people, those analysts, right, they're not out of a job. Their job changed. It's the same thing with DevOps, right? With AWS and the cloud providers, everybody had their own thing. They had to have massive teams of DevOps people because they had to manage their own cloud, right? And here comes the cloud, here comes AWS and Microsoft Azure. And they say, no, we take care of this. And the majority of the DevOps people, and this happened also with analytics and everything else, they're resistant. They're like, wait, you're going to take my job away. I don't want this, right? And they're going to be a blocker as much as they can because they see it as they're going to take my job. And look at what happened. The cloud has won, clearly, and DevOps people still have jobs, right? Their job got elevated. They're now much higher level type of management in companies. And that's the future of the data scientists. The few data scientists, and by the way, most of these people that have these jobs now, they got displaced and then went back and saw the new opportunity. Most of these people were not ahead of the curve. And the data scientist Instead of saying, I'm going to be the only person in my company that's AI literate, I own building models and my small team, their job is going to be, wait, now there's 400, 500, 2,000 people in my company that are going to ask their own questions and build their own models. My job is going to be to oversee all of that, to manage, to be like the transformational leader for AI in the company. I'm going to be the one that makes sure everybody understands how to formulate problems, how to think about AI. I'm going to let them use these tools and build their own models. And I'm going to help them make sure that they're using it correctly, right? And so much higher level type of job. I think fantastic type of opportunity. But it's a different role. A role that, if you just look at history, it's going to happen, right? It happened with DevOps, happened with analytics. You could probably pick easily 6 more of these. It always happens that way. When you have something as powerful as AI, it's never going to be that, for the rest of eternity, only 6 people within a company can do it. It's too valuable for that to be the case. Anything that's that valuable, the company's going to figure out quickly as possible how do we get that and make everybody in the company AI literate. And hopefully, the data scientists that start that process soon will be the ones that become the famous leaders of tomorrow, right? The top chief data scientists and transformational AI leaders that say, I made my entire company AI literate. That's the future of the data scientist. It's a good future.
I think the closer technologists get to business, that's where the power of their strength comes out. I think actually, I agree with you 100%. If you've been looking at the evolution of technology's bleeding more into the core revenue producing parts of the company. The more you're able to see where the optimization is, the ability to automate, the ability to produce more effort with less. I think that's where the power is. So I actually agree with you. I think that my background was old school SQL Server BI, and I built for a cargo company back in the day. We built an analytics tool. It was an ASP 15 years ago, and it was a hell of a project to build because it took a lot of lines of code, and it was primitive, but they were blown away. I think now that same thing is probably kicked out of Excel, 10 times what it could do in the hands of an analyst. And to your point, these data scientists, the business value, coupling that maybe with an MBA, understanding like functional areas within a business, domain specific, I think that's going to be a big win for everybody in the end. So I guess let me ask you this, and I know I actually love what you guys are doing because it's practical. Like it's really out there, it's being implemented. But obviously for a second you went to the tangent of the future of the role of data scientist. What do you see particularly in terms of everyone says X million jobs, it's going to be $15 trillion worth of value generated from the implementation of AI over the next decade and a half or whatever that number is. Like what's your if you're looking in your own personal view of your crystal ball, like where do you see the big wins coming so that snowball can actually start taking fruition?
So I think that there's going to be what we call a data scientist today. That demand is going to quickly turn and go down, because the moment people realize that they can have hundreds of people in their company fulfilling this role, right? That's going to be the data scientist 2.0. It's no longer the person that spent 12 years in school, right? It's the person that understands the business and can use a tool, ask the question, answer the question. And that's data scientist 2.0. And by the way, and that's how I think, there's a big win. The moment a company goes under that transformation of we're now AI literate, we now have hundreds of people that can do this, that's huge win. The data scientists of today are going to end up in 2 roles. One is the one that I described before, which is a transformational leader. And the ones that are, they like the technical aspects of their job better, they're going to be the researchers that develop new AI technology, right? The way I see the data scientists today, and by the way, the role that I had, right? The role that I had for years, I saw it as an unfortunate waste of talent, waste of time, because we learn so in depth everything that we do. It's like hiring a jet engine engineer to fly a plane. It's like, yeah, sure, they could fly the plane, but Can you make the plane easier so that other people can fly it? And then you use that knowledge that you get to invent the next generation of jet engines? Because that's where, the value is really for people that are that technical. So that's going to be the other role for the data scientist of today, is going to be invent the next generation of AI, and solving the problems that can't be solved with current AI technology, right? Those are going to be the companies that still need to hire these kind of people that, hey, yeah, we have these other 5 problems. Just today, we cannot solve them, period. Get the team that's technical enough to invent a solution around that problem.
So the data scientist 2.0, the title that I've read several times now is called a citizen data scientist.
I don't like that title.
I don't like it either. I don't get it. I was like, I didn't know if you want to touch it. I was like, I don't know if
I don't like that.
Yeah, I don't like it either. 2.0 works for me, but I'm sure there'll be some evolution of that title.
Yeah. And by the way, I don't think they'll have that title. I don't think data science will be probably not in the name.
I agree. I think there'll be a lot of domain specific knowledge worker type people that can leverage these pre-existing tools to do what you say. I think that's where that PwC report was alluding to, was that once you put this in the hands of people, much like what Excel did to most of the corporate world 20 years ago, I mean, all of a sudden everyone created their own Excel spreadsheet version of their truth. This is that times a billion in terms of power. So it'll be very interesting to see when that actually happens. And obviously you guys are already doing it. So that's really cool. I did mention previously when we started, I typically ask one scripted question about learning lessons, and you had a very good take on it. And I'm cognizant of our time. But if you had to, and I'm going to let you respond to the way you responded to, so I'm going to let you respond to it. If you had to go back, obviously you've been running Ople.ai for a while, and if you were going to apply a learning lesson to what you've experienced, if you had to change something you've learned that you'd apply, what would that be? So
I get that question a lot, and my answer is always the same. It's the honest answer, which is I wouldn't change anything, whether it's in my company or in my life. And some people interpret that as being, conceited. Oh, you never made a mistake, and that's not it at all. It's just I'm happy where I am today, and the moment you introduce a change in the past, right, that could change where you are in the present. So I would never want to risk not being where I am today with Opal. So yeah, I could go back and fix something and not be here today, right, and be in a different place, and that's too risky for me. So the answer is nothing. I wouldn't change anything because of that. Now, going forward, right, in the next company, or in going forward in the next years in this company, I can certainly use those lessons and apply them going forward. And I think the 2 biggest lessons for me are not to read too much into signals, meaning getting overblown type of reactions to signals, and thinking one type of signal is you have product market fit, and then getting ahead of yourself before you really do. It's really easy for founders to do that. And then the second one is being more decisive. And sometimes there are going to be decisions that are really tough, and they're kind of ruminating with you and for a while before you actually make them. And if you feel it and you really know that it has to be made, just make it. Don't wait too long to make these decisions. Those are the 2 aspects, which is funny because one is make sure you don't move too fast. The other one is make sure you don't move too slow. And it's that complicated, and it's never easy. So it's not going to get easier because, the following lessons are going to be the reverse. But yeah, that's what I think.
That's interesting. I like that. Let me ask you this, because I think you actually responded to this kind of uniquely. But the one thing I want to take out of this, so as a person, you obviously wouldn't change anything because obviously you are where you are. Anything changes, it changes the outcome. How do you deal with do you deal with regret? I mean, in terms of your philosophy because of what you just stated, or is there regret, but you just deal with it differently?
No, it's human nature to feel regret, and I try to cut it short, just cut it really quickly, because I force myself to go through the exercise of, the moment that feeling is seated in my brain, I say, okay, stop. what would happen if you had done it differently? And then the answer is, I don't know where I'd be today. And sure, there's always a probability they could be in a better place today, but it's also a probability you could be in a worse place today. And being grateful and happy with where you are is really easy to then say, yeah, there's no way I can regret any of these decisions because, again, just remember, be grateful for where you are, and then you wouldn't be here if it weren't for even the bad decisions you've made. So then I cut in the bud really quickly whenever I get that feeling. So I think I do a pretty good job of managing that and not actually having regret. But you turn that into something positive, which is, what's the lesson going forward? And then just go from there.
Yeah, that's awesome. I actually personally I believe in that just because I look at it and I go, people always go hindsight's 2020, and I'm like, you have no idea what that alternate universe would have been if you'd have decided between option A and B, and you would have picked B instead of A. If you're not happy with what A is, B doesn't necessarily mean it would have been better. It could have been worse. You could have been hit by a bus because you turned right instead of left. I mean, who knows? So I agree with you. We just can't ever look back and extrapolate that the other decision would have been better. Very, very interesting thoughts. I appreciate you being on. It was really fun, really interesting to see how you guys are, touching on actual, implementation work, getting actual projects, greenlit and moving forward in AI space.
Thank you. This is a lot of fun.
That's it for this episode. I'll be back again with a different guest, a different topic. Until then, please like, subscribe, share, leave a comment wherever you are watching or listening to this episode. I can't thank you enough if you do. Until next time, thank you and goodbye.